So we're going to start a new group of chapters, and they're going to involve graphing. And we're going to be graphing on what's called the coordinate plane, which is the title of chapter 22. And so we have chapters uh, 22 through, let's see, 27, where we basically lay the groundwork, the basics for graphing lines. Okay, so with 22 and 23, we're going to group those into one video because they're so short. They're about 3 pages per chapter. And 22 just talks about what the coordinate plane is, which you can see that here below. And then in 23 we talk about a little about linear equations. Okay, so what you see here, we have a grid. All right, grid of squares, and we have two main axes. You can think of these as two individual number lines, and we dealt with number lines in the previous chapter, but we only had one. Okay, and we used the horizontal number line. Negative numbers were on the right, positive numbers were on the left, and we had to use those to graph the solution to inequalities. Well, we're going to use them a little bit differently in this chapter. We still have the 1, but it has a specific name now. We call this axis, the horizontal one, the x-axis. Okay, and so any point that we find on this two-dimensional surface, say for instance, if I pick this point here, okay, it has a location with respect to the x-axis, and if we were to use units of 1, then in this x-axis again is a number line. Then we have several locations along the number line. The right is positive, and so if we were to say each unit is 1, then any point that falls along this vertical line here would have the x coordinate of 1. And so with this two-dimensional plane, we don't have to have points that sit directly on top of these number lines as we did before. They can be offset to the side. So this location, this vertical location on the 2D plane would be x equals 1. Any point along this vertical line would be x equal 1. Any point along this vertical line would have the x location of x equal 2, which is the x coordinate of this point here. It's positioned directly above x equal 2. And so we have other locations along the x-axis, 3, 4, and 5. This location on the x-axis in the center is 0. So if you just look at this horizontal line, this x-axis, as a number line, then when we jump over to the left of 0, we have negative 1, negative 2, negative 3, and so on. Okay. Next would be our second number line, and we position it vertically with respect to the x-axis. So likewise, again, this here's our y-axis, the vertical one, and it's a number line just like the x-axis was. With the y-axis, just like we said for the x-axis, the right side uh, from 0, and here is x equals 0. The right side is a positive number, so which side, top or bottom, are the positive numbers for the y-axis number line? Well, the top is, which is kind of intuitive. So if this 1 square represents 1 unit, up or down, then this first mark on the y-axis would be 1, the second one would be 2, 3. Okay, it's just like the horizontal number line, except we've oriented it to where it's completely vertical. And so the bottom part of the y-axis begins our negative numbers, -1, -2, -3, and so on. Alright, so with respect to the y-axis, if we have a point that falls along this horizontal line anywhere in the 2D space, anywhere within this grid, if it falls on this horizontal line, then we say that it lines up with y equal 1 coordinate, and so the y coordinate of this point would be 1. Okay. Likewise, let's say we picked one point on this horizontal line way over here to the right. Well, this point also lines up with the y-axis at y equal 1, so its y location would be 1. So there's several points on this 2D surface, two-dimensional surface, that have the y coordinate of 1. Okay. Now for the y-axis, we also have a 0 on the number line, and it is right here. This is y equal 0. And so this point is shared by both the y-axis and the x-axis. And it has a special name. It's called the origin. Alright, now since we've already talked about points having an x-coordinate and a y-coordinate, we can assign coordinates to the origin. And we assign coordinates to a specific point with two coordinates. Okay, this is called an ordered pair here, and the way we usually write coordinates on a coordinate plane is we write the x first, the y coordinate second, we place both of them inside parentheses, and we put a comma in between them. So at this location, this point where the two axes intersect, the x and the y equals 0 and x equals 0 at this point, and so the coordinates are 0 for x and 0 for y, 0, 0. And so this is our origin. Whenever we're locating a point on the 2D plane, we start at the origin. Okay. So we've talked about the x-axis, positive on the right, negative on the left. We've talked about the y-axis, positive up and negative on the bottom, down from the origin. And one last thing that we can mention about locations on the 2D plane, the coordinate system, is you can see that with two axes intersecting, we've divided this grid up into 1, 2, 3, which I'll write in Roman numerals. Hold on, that's not 3. 1, 2, 3, and then 4. We've divided it up into 4 different quadrants. That's what these are called. Uh, and these are the specific numbers that we assign to them. Sort of a weird way to do it, I suppose, but the upper right quadrant is quadrant 1. And then we go counterclockwise. So counterclockwise to name the quadrants. And so we have 1, 2, 3, 4, and there's only 4 divisions with respect to the x-axis and the y-axis crossing. So there's only 4 quadrants. So here's sort of a summary of what we talked about on the previous page. Horizontal and vertical number line, the x and y axis. We pointed out where the origin was and what the coordinates of the origin was. We talked about the x-axis and the y-axis in terms of positive and negative numbers, and then we just labeled the quadrants. And so the bigger purpose of this chapter is to learn how to plot points. Okay, find the location of certain points using the x and y coordinate. And so I've already mentioned that ordered pairs are used for coordinates on the xy plane. And the x coordinate comes first in the ordered pair. Then we place a comma, and then second is the y coordinate. We always list coordinates on the xy plane with the x first and the y second, always. Alright, a lot of times when you're plotting points, you're just given a grid like this, and there's no numbers on it. And so it's always a good idea to take your x and y axis and at least point out how large one unit is. And so in this case, if I put a mark here and I labeled this mark on the x-axis 1, then I'm saying this distance, the width of one square, is 1 unit. Okay, and so if I go over one more square, then I would know that this is 2 on the x-axis. Likewise, you want to do the same thing with at least one tick mark on the y-axis. I'll keep the same units, the same scale on the y-axis. If I go up the length of one square here, then I'm just going to simply label that with a +1 on the y-axis. Okay, and this tells the reader what you consider to be 1 on either x or y axis. It's very important. So if you have a blank coordinate system, this is the least that you should do. Another thing that you can do is label the axes x and y, and we usually label the x and y at the positive ends of the coordinate system. Okay, but that's not entirely necessary, but just make sure you put your units on your grid. So with example 1, we want to find the location, and we'll call this point, we'll label it on our coordinate system A. And so we are given the pair of numbers -2 and 4. So x equals -2, and then y equals 4. That's what this pair of coordinates tells us. So let me clear my grid, and you know that 1 is the width of one square. So where is x equal -2? Well, if we start at the origin, this is x equals 0, and whenever we're locating the point, we start with the origin and we use the x coordinate first. And since it's negative, I want to go to the left, okay, from the origin, and I want to go 2 units, so I go 1 and then 2 more, or 1 more for 2. And so this would be the location, and this is temporary, this would be the location of x equal -2. So with just that one coordinate, I know that the point A is going to be somewhere along this vertical line. Anywhere along this vertical line, we have the x coordinate of -2. Now, I want to couple that with my y coordinate 4. What kind of number is 4? Well, it's positive, and so with a positive number, we go up. And so once again, we start at the origin, and I go up 1, 2, 3, 4. And so here is y equal 4, and anywhere along this horizontal line, my y coordinate equals 4. Well, I want the point to have both of these coordinates, 4 and -2, and the only place where that happens is where these two dashed lines intersect. And so this is the actual location of -2, 4, and I'll label it with an A. Alright, what about this next point? Well, it's point B. That's the way we'll label it on the 2D plane. And I have an x coordinate of 0 and a y coordinate of 3.5. Alright, so I go to the x-axis and I start at the origin. This is where I'll start, and x equals 0 right here. And so with x equals 0, that means that I do not go right or left. I just simply stay here along the y-axis. Okay, so anywhere along this y-axis, any point on the y-axis satisfies this first coordinate, x equals 0. So I know I'm going to fall on the y-axis, but where at? Well, for the y-axis, the y-coordinate, I read the coordinate 3.5, and so I go up because 3.5 is positive. 1, 2, 3, and I don't want to go up a full unit because that would be 4. This is 3. This is 4, and so for 3.5, I go halfway in between, and I place my point at y equal 3.5. And so here's my coordinate, my point, with the coordinates 0 and 3.5. C, we have x equals 2.5, and for the y-axis we have y equals -1. Alright, so again I have this partial unit 2.5. I go to 2 and then I go halfway to 3. So we start here at the origin, and with the x coordinate coming first, that means that we go left or right first, and since 2.5 is positive, I go to the right, and I have to go 1, 2, and then a half. So I know my point is going to fall somewhere along this vertical line, because this is the location of x equal 2.5. Now, y equal -1, well, we start at the origin again, and we go down 1. I went down because the 1 is negative, and so I went down by the amount of 1 unit. And so wherever this x and y coordinate intersect is the location of point C. And so we'll label it, we'll put a C beside it. D, we have x equals 3.5 and y equals 0. Alright, first coordinate, x 3.5, it's positive, so we go to the right from the origin 1, 2, 3, and then a half. And so this is all I know is x equals 3.5, and so I know my point just by reading one coordinate. My point falls somewhere along this vertical line, and so then what we do is read the y coordinate, and with the coordinate of 0 for the y-axis, we don't move up or down. Okay, y equals 0, we don't go up, we don't go down, we just stay right here on the x-axis. And so I'd place my point right here, and I'd label it with a D. And so by plotting all of these points, we've learned two other things about the x and y axis. We've learned that all points along the x-axis have the coordinate, the y coordinate of y equals 0 axis. And then for the y-axis, and these are important, as simple as they are, it's important to know that anywhere along the y-axis, your x-coordinate is going to be 0. Anywhere along the x-axis, your y-coordinate is going to be 0. Example 2, we're going backwards with respect to example 1. Here we're given points on the 2D plane, and we want to figure out what the coordinates are. So for A, here is point A. We start at the origin. We want to write our coordinates in terms of an ordered pair, so parentheses, a comma, and 2 spaces. Okay, you want enough space to put your numbers in here. Now, to figure out the coordinates, we start at the origin. The first coordinate that we're going to place in our ordered pair is the x, and to get to this point, we only want to move horizontally and vertically. And so what we can do is start from this point and trace our way back to the x and y axis in a straight line manner. Okay, a vertical line to get back to the x-axis, a horizontal line to get back to the y-axis. Alright, what is our y, or what is our x coordinate? Okay, because with respect to the x-axis, A is positioned directly above this location on the x-axis. So if we go over 1, 2, 3, 4 to the left of the origin, that tells us the number 4, and then we went to the left on the x-axis, and so that would tell us that this is a -4. Okay, what is the position of A with respect to the y-axis? So we look at this horizontal line it's projected over to the y-axis, and we start at the origin and we go up 1, 2, 3, 4 to get to this location. So in other words, the y-coordinate of this point A is 4. We went up from the origin on the y-axis, and so this 4 is a positive 4. And so this is the procedure that will follow for the rest of the points on the coordinate plane. So for point B, we will track our way back to both axes in straight lines, horizontal to the y-axis, vertical to the x-axis, and then we'll figure out where these lines cross the x and y-axis. So starting from the origin, we read our x-coordinate by going to the right 1 unit. So by going to the right, it's positive, and the number is 1. So for the x-coordinate of the ordered pair, we write +1. Now, what number on the y-axis does this point line up with? Well, from the origin, we go up 1, 2. We went up, so it's a positive 2, and so we place 2 in the second spot of our ordered pair. That takes care of B. Where is C? Well, here is the location of C with respect to the x-axis, this vertical line. Here is the location of C with respect to the y-axis, this horizontal line. Alright, so we'll start with the x-coordinate. From the origin, we go to the right, so it's a positive x-coordinate, and we have to go over 3 spaces. And so this is x equals 3. And then to get to the y-coordinate, we go down from the origin 2 units. And so for the y-coordinate, we would write -2. That takes care of C. And now D. Alright. For the first coordinate, the x-coordinate, it's directly below the origin. So in terms of the x-axis, we don't have to go right or left. We just go straight down. Okay. So in other words, D is aligned with the x-axis at the location of x equals 0. So like we said above, if a point is on the y-axis, then x automatically equals 0 in terms of the coordinates. So for D, we have 0, comma, but we do have to go down to get to D 1, 2, 3 units from the origin. Down from the origin would mean that we are in the negative region of y, and we went down 3, so the y-coordinate would be a -3. Alright, so pretty straightforward. You just need to get a little bit of practice so that you don't make any simple mistakes. Alright, linear equations, chapter 23. All linear equations can be placed in the form of ax plus by equals c. This is called the general form. A and b are referred to as coefficients. Alright, these are just simply numbers that can be placed in front of x and y. So for instance, to come up with some linear equation, it's real easy. You just use this as a template, and you pick any numbers that you want to for a, b, and c. So I could write out an example of a linear equation if I picked A is 2, and I put an X behind it. And let's say B is 3, and then I put a Y behind it. And then C, I don't know, it could be any number. We could pick 9. And so we can do this all day. A, B, and C can be negative numbers, they can be fractions, they can be decimal numbers. It doesn't matter. As long as you put it in this standard or general form, as the workbook calls it. Two other things that you can pick up on by looking at this so-called template is we have an X and a Y variable. Those are the only options. Alright, 2 variables, not 3. Okay, only 2 variables, and each of the variables have an exponent of 1 only. If you start playing around with the exponents here and you use something other than 1, then you're going to get a curve. It's no longer going to be a straight line, which is what linear implies in the title of the chapter, linear equations. So we're only talking about straight lines here. Just to give you a couple more examples, we could write negative 1x plus 3/4 y equals 0. Okay, and if C can be 0, then that also means that A and B could be 0. So we could write a linear equation with A being 0, 0 times x plus, let's say, 2y equals 4. And another version of this same linear equation would come from the fact that 0 times x, it doesn't matter what x is, 0 times x is going to be 0, and so what we can do is just erase this term here and rewrite this as simply 2y equals 4. This linear equation is the equivalent to this one. They're the same line. Alright, so that's just to give you an idea as to how to recognize a linear equation. Okay, you have 2 variables. Each one of them only has a power of 1. We do not have a variable in the denominator of a fraction. And as far as that goes, that pretty much sums it up. Okay, so we'll clear that and we'll move on down the page. And we'll run up on a question that says find 4 solutions to x plus y equals 3. Alright, so in the previous chapters where we solved an equation, we usually just had 1 variable, but now we have 2. And so a solution is represented by an ordered pair. So it wanted 4 solutions, and so for a solution for each one, we're going to have 2 numbers, an x and a y. So they give us 1. They say that 2 and 1 represent a solution. Why is that? Well, if we plug 2 in for x, one in for y, then it satisfies the equation. 2 plus 1 is 3. It checks out. So to put it more simply, we're just looking for 2 numbers that add to give us 3. It could be any 2 numbers. We could say 0 and 3. 0 plus 3 is 3. And so that would represent a solution to this equation. We could reverse the numbers and say x is 3 and y is 0. That is a different solution. Okay, these are not the same solution. We've swapped the numbers for x and y. And let's see, we could have fractions as a solution. So if I picked a half for x, then I would have 2.5 left for y, because these two have to add to give us 3. And for a fifth one, I could pick negative numbers. Let's say if I pick negative 2 for x, then I'd have to pick 5 for y, because negative 2 plus 5 is 3. So this satisfies the equation. It's a solution. A solution to a linear equation requires two numbers, because there are two variables. Example 1. We have some linear equations, and I know that because there's two variables, only two, and the variables in each equation only have exponents of 1. Okay, exponents aren't given, so it's understood to have an exponent of 1. Okay, it says find the solution to the linear equation. And some of them may be simple. You may be able to just guess some numbers. For instance, if I have 6 here, if I choose 1 for A and I have 6 here for this quantity, then I need one more to make 7, but I have a negative here, so if I pick a negative 1 for B, then I'd have minus 1 plus 1, so 6 plus 1 equals 7. A, B equals, what did I use, 1 and a negative 1. Okay, so sometimes you're able to play around with the numbers without actually doing a whole lot of math. But let's say you had a complicated equation. Okay, what would you do then? One where you couldn't think out what the two numbers should be in order to give you the 7. Well, you would go about that by, first realizing that a solution is going to be represented by two numbers, and you start out by just picking one of them. So let's make it easier on ourselves, and I'll pick 0 for the x, or in this case the a. So if a is 0, then that means I can place 0 in here for a. I don't know what b has to be. Okay, if I pick 0 for a, then b is sort of going to be locked down, and I have to figure out, I can't just put any number here for b. 0 times 6 is 0, and so I have 0 minus b equals 7. Alright, which gives me the equation negative b equals 7. So once you pick one number for a particular variable, you're only going to have one variable left in the equation, and we spent a lot of time in previous chapters figuring out how to solve for that one missing variable. And that's what we're doing now. We have negative b equals 7, so b would be equal to a negative 7. So here is one more solution. We found one solution, 1, negative 1, and now we found a second solution, 0, negative 7. Okay, the next one, we'll just start out by picking one number in the ordered pair, and our policy for the ordered pair in this class will be, we use alphabetical order for the variables, so U comes first, V comes second, so our ordered pair would naturally be arranged this way. Just like X and Y are in alphabetical order. So this is how we'll arrange the ordered pair. I start out by picking a number for one of them. Easiest number to use a lot of times is 0, and now plug the 0 into the equation. Okay, pick a number for one of the variables, 0 for u. Now I put that into the equation. I have minus 0 plus 5v equals 8. Alright, I didn't mean for that point to be there. I don't want you to think it's a 0.8. This is a 8. Okay, so we're not going to get a pretty number for v, but this 0 knocks out that one variable, and so we're just left with 5v equals 8. To solve for v, we divide both sides by 5, and so we get v equals 8/5. And what we do at this point is we just go back over here and we complete our ordered pair. And so the solution is 0 and the 8/5. If u is 0, then v has to be 8/5. There's no other option for this number. So once you pick one, that nails down the other one. You just have to do a little bit of work to solve for it. So we're supposed to do 2. So there's 1. I'll go back and I will erase all this other stuff because we're going to pick a different value for u. We could choose the easy way out, and instead of picking u, I could use 0 again, except in the place of v. That would give me the equation minus u plus 5 times 0. And now that knocks out the 5. 0 times 5 is 0, and so I'm left with negative u on the left equals 8. And if I swap the negative over to the 8, I get u equals negative 8. So this represents a different solution. So I go back, this is my previous solution, and now I want to complete the one I just calculated. V is 0, then u has to be a negative 8. Okay, these two numbers are tied together. If I have a negative 8 for u, then I'm going to get a v for 0. Alright, so here's our two solutions, and so we'll move on to part C. I need to make some more space. So same procedure. If I want to find a solution, then what I do is I pick a number and substitute it in for one of the variables. You don't always have to use 0. If you want to switch it up, you can pick something like 1. It's just that 0 makes the equation so much easier to solve. But you don't have to pick 0. If we use 1 for m, then we get 3 times 1 plus n equals 4. And so we get 3 plus n equals 4. To solve for n, we subtract 3 from both sides. So n equals 1. Okay? Which is just a coincidence. I picked 1 for m, and it turns out that n has to be 1 too. So alright, so we found one. Let's find another one. We don't want to use 1 again for either one, because 1 is paired with 1. So if I used 1 for y, then I'd end up with the same solution, 1 for x. So we don't want to do that. We want to pick a different number at this point. And so let's see. Let's try -1. Okay, m equals -1. So what is n? I take my equation. 3 times m is 3 times a -1. Alright, and with a -1 in the place of m, we're going to get a different solution now. So 3 times -1 is a -3 plus n equals 4. Solve for n. We add 3 to both sides, and we get n equals 7. Different ordered pair, different solution. So here's the second one, -1, 7. And you can do this until you're blue in the face. There are an infinite number of solutions. You pick a different m, you'll get another solution once you solve for n. Alright, so I just answered this question down here. There's infinitely many solutions. Many solutions. And the reason is there's infinitely many possibilities for the number that I can replace m with, and every time I replace m with a different number, I get a different n. So numbers never end. There's infinitely many numbers for m, and so infinitely many solutions. So we'll clear that part, and we'll move on down here, and we'll look at the table, which is another thing that you're going to see over and over again in any of your algebra classes, trigonometry, calculus, if you get that far. You may not have to, but a table just consists of 2 columns if we're graphing a linear function, and 1 column we put x values in, and the second column we put our y values in. And here we already have x values chosen for us, -6, -3, 0, and 3. And here we have our rule. Alright, you could look at a linear equation as a rule. It tells you if you're given x, what do you do to it to calculate y? Okay, so -3 times x minus 4 is sort of a rule. It means that we would take -6, okay, it's telling us what we do with x. Take -6, multiply it by -3, and then subtract 4 from that. And so that is our rule. That's how we relate an x value to a y value. So -3 times 6, -6 gives me 18, minus minus. I subtract 4, I get 14. So to start completing our table, we would go to the y column. Ultimately, I have y equals this, and along the way I put the numbers in and I did the calculation. So in the end, I have y equals 14. So I put 14 in the column right beside the -6. Okay, the x value that gave me the y value of 14. So this is our rule. Multiply by -3, subtract 4. If x is -3, I replace the x with the -3, so now I have 2 -3's multiplied times each other. One came from the x, the other one came from the rule, and now I subtract 4. -3 times -3 is a +9. If I subtract 4, I get 5. Okay, and so I place the 5 beside the -3 in the y column. Next one. Okay, so I create a blank, multiply by -3, subtract 4. The number that I want to put inside here is a 0. Alright, 0 multiplies to -3, so that sort of takes both of those down along with it, and we're only left with a -4. So for x equals 0, y equals -4. And what if x equals 3? Well, y equals -3 times whatever number x is, and in this case it's 3. Then we subtract 4. Well, 3 times a -3 is -9, and then we subtract 4 more, and that would be -13. Okay, now it says each one of these can be plotted. Solutions may be plotted as a point on a graph. Alright, so if you wanted to know what a function or an equation looked like, then you would do this. You would start off by creating a table of values. Each one of these pairs of numbers, x and y, graphically gives you an ordered pair to locate on the coordinate plane. It gives you a -6 and 14. Here is this represents one point on the coordinate system. Gives you another point, -3, 5. A third one, 0, -4. And then a fourth one, 3 and -13. If you was to plot all four of these, you would see that they fall in a straight line once you connected the dots. Okay, that's why we call it linear. It's a straight line. Alright, graphing a linear equation of the form y equals mx. Graph the line y equals -x. And just to be straight with you, there's actually several ways that you can graph lines, but we're going to stick with what we've learned in this chapter, which is to create a table of values for x and y. So normally what we do is we lay out our table, x, y column, and we pick x values. So I'll pick 3. Let's say -2. 0 is always a nice number to pick for x, and then +3. Okay, I picked a negative, I picked 0, I picked a positive number. And so at this point what we do is we take our x and we place it in the equation. Now notice that this one, y equals -x, is the one we want to graph. And if you can't really see that, there is a negative placed in front of the x. So what this function does is it takes our x number and it changes the sign. So if I put in a -2 in the place of x, then I have to place an additional negative in front of it. This negative is associated with the 2, the number that I picked. This negative on the outside came from the negative in front of the x of the equation that I'm trying to graph. So I have to have both of these negatives here, and a negative makes a +2. So it changed the sign of our x. Now if I plug in a 0, the sign doesn't affect the 0. -0 is the same thing as +0, or I could just simply write a 0. 0 is a neutral number. It doesn't have a sign really. It just turns out that you can put any sign in front of it that you want to, and it's the same number. So for x equals 0, I get y equals 0. So this line crosses through the origin. And finally I have x equal 3, and if we place that in the equation we're given, minus and then the number x, I have minus and 3. So it changed the sign again. I have a negative 3. So if I picked 4 and I added that value to my table, then I just simply say for y, negative 4. So we have plenty of points to plot here. Negative 2, 2 means that I go over 1, 2, and then down 1, 2. Up. I got in a hurry. I want to go up. So with x equal negative 2, I go to the left, negative 2, and then I go up because 2 is positive for y. So this is where negative 2, 2 would land. Alright, I don't want to have a messy graph, so I'll erase those. And then we have the origin as a point on our line. That doesn't always happen. So I just put a point right here where the axes cross. And then I have the point 3, negative 3. So I start at the origin, and with x equal 3, I go 1, 2, 3 to the right, and then I go a negative 3 down 3 on the with respect to the y-axis. And I land right here. And so you can sort of see already that these points are just falling along in a straight line. If I pick x equal 4, then what ends up happening is I go over to the right 1, 2, 3, 4, and then I go down 4 for negative 4. And so if I put in any of these numbers along the x-axis, for instance x equal 1, then I'd go down 1. X equal 2, I'd go down 2. And so any of these points would fall along the line graphically, and any of these points, the coordinates would satisfy this equation. So at this point we just simply draw a line. I'm doing the best I can to make this straight. And we can't draw it forever, so what we usually do is we just place arrows at the ends, and we make sure the line connects all of our points that we plotted. So this doesn't just work for lines. If something's curved, you may have to plot more points, but if you don't know what something looks like, what you can do is just start off by creating a table of values x and y, transfer them to your coordinate plane, and then connect the dots. But for intro algebra, we're simply just going to deal with lines, straight lines. Alright, so we have a little bit left, chapter 23, just one more example, and we'll stop, okay, because the next page starts chapter 24. So example 4 says identify solutions to a linear equation in two variables. So here is our equation, x plus y equals 3. Is this a solution to the equation? Well, this, just by giving us this ordered pair, they're telling us two things. They're telling us x is negative 4, and they're telling us y should be replaced with a 7. Well, does this actually work for the equation? That's what we want to know. And so I take x and I go down here and I replace it with a negative 4. I take y and I replace it with a 7. I add the two numbers together and it checks out. 7 minus 4 is 3, and that matches the right hand side of the equation. So yes, negative 4 comma 7 is a point on the line because it's a solution to the equation. Okay, they give us a second point, 5, negative 1. Is it a point on the same line? Well, we don't have to graph it. We just have to use this equation, which says that we want to add the two numbers, x plus y, so 5 plus a negative 1. Well, what does that equal? 5 minus 1, that gives us a 4. but that does not match the right hand side of the equation, or the right hand side of the line. So 4 does not equal 3. 5 negative 1 therefore is not a point on the line. So if it's one, then it's the other. Alright, a point on line is a solution to the equation, and this goes for any type of equation, whether it's linear or not. A point on the line is a solution is a point on the line. And with that, that completes chapter 23.